how much LSD should you give an elephant? Well, to a reasonable person, the correct answer is probably none. But what if you needed to do it for a scientific experiment? In the 1960s, the CIA was working on a top-secret project known as MKUltra, and one of their main goals was to find out how drugs like LSD could be used to change human behavior. And this is where elephants come in, because elephants are normally quite docile, but sometimes they just snap. And the hypothesis was that this change in behavior might be triggered by the release of an LSD-like substance that naturally occurs in their brains. So if that's true, then administering LSD to a docile elephant might reproduce that behavior. So the real question was, how much LSD should you give an elephant so that the dose is large enough to cause a psychological reaction, but not so large that it causes harm? Well, the researchers didn't know. LSD had never been given to an animal that big. But they did know that the safe dose in cats was around 0.3 milligrams. Now, since an elephant has around 1,000 times the mass of a cat, they figured we'll give it 1,000 times the dose. They received approval to perform the experiment on Tusko, an Indian elephant at the Lincoln Park Zoo in Oklahoma. And there, they injected him with nearly 300 milligrams of LSD. But within 5 minutes, Tusko trumpeted, collapsed, fell heavily onto his right side, defecated, and went into status epilepticus. They administered a few other drugs in an attempt to revive him, but Tusko died shortly thereafter. The mistake they made was to assume that safe drug dosage scales linearly with mass. It does not. And it turns out there are a lot of things like this that don't scale in the way you'd expect. For example, take the smallest mammal by mass, the Etruscan shrew, and the largest land mammal, the African bush elephant. Which do you think has more heartbeats over the course of its entire life? Well, an African elephant has around 1 billion heartbeats in its lifetime, and an Etruscan shrew also has 1 billion heartbeats in its lifetime. What about a wallaby? Also 1 billion. A two-toed sloth? 1 billion again. Just about every mammal, no matter what environment they live in, how large they are, or even whether they live for 1 year or 100 years, they all get around 1 billion heartbeats between the day they're born and the day they die.
Why 1 billion? Why not 1 million? Why not 1,000? It's not these other numbers.
That is, every mammal except one. This video is in large part based on the book Scale by Geoffrey West. If you want to learn more, I'll put a link to it down in the description. What's even more curious is that just by knowing a mammal's mass, you can predict a staggering number of biological traits, from its pulse rate and reproductive output to its total lifespan. The same pattern holds for cities. If you know the population and location, that allows you to forecast everything from average wages and patent filings to crime rates, disease prevalence, and even the literal speed at which pedestrians walk. So how is that possible?